lecture, I'll be talking about time series plots and three-dimensional graphs. Time series data is an important form of data. In many applications, date and time is important. The good news is that Python has ways to help graph it. Several libraries can be used to visualize time series data, and you have seen two of them before: date time, and calendar. When we wanted to measure the algorithm's running time, we imported time module. And when we were talking about SQL scripts, we use date time as one of the data structure. And you can see those two libraries here again. So times can be difficult to deal with from programming point of view. Arithmetic operations can fail, and we cannot use arithmetic numbers to present them. Datetime module helps with this issue. Data types in datetime module include date, which stores calendar date like year, month, and day. Time stores time of the day as hours, minutes, seconds, and microseconds. Datetime stores both date and time delta represents difference between two datetime values. So if you want to know the current day and second, so you use datetime.now. Datetime.now minus datetime date is the time delta object. So it returns the time difference between two date times, right now and a specific date. Pandas library and data frame can be used to store time and date data. For that, we use date underline range. So it's like a range function, but its type is date. For example, you want to generate dates starting from 2012, month 3 and day 1st, through 2012, month 4 and day 1st. So you can give a start or end and then a period. You can also pass another argument named frequency. So do you want to generate the range based on days, based on business days, or hours? So let's implement this in a notebook file and you can see what it looks like. So first we import important libraries like Pandas, Numerical Python, Matplotlib library. Here we are using the Pandas, so we pd.date underline range from 2012 month 3 to day 1st. Then the second argument, 2012, the same year. The 4th month and 01. Okay, so you can see, okay, starting from a range of dates, 2012, first day, second day. So by default, if you look at the frequency, is D. Now, if you want to change it to just business days, then you add frequency equal to B. And then it generates based on the business days. Or if you want to generate based on hours, then you change frequency to H. And then you can see hours plus for each date. Now we want to plot time series. Using the date as the x-axis and some other values as the y-axis is most common when looking at time series data. For example, we want to track how variable y changes over time. Matplotlib library handles this quite well. So we use dates as x and we add y or y as appropriate for the problem. Here is an example. First, we create a random 3-column by 40 row numerical Python array. Then we create a pandas data frame that starts at March 1st, 2012 and goes for 40 business days. Then we want to plot all 3 lines on one figure, and then we customize the lines. And we add a legend, and we make up names for columns or products. So the columns represent like 3 variables, and rows are the date. Here you can see the code. So first we import libraries. Here we are using datetime, pandas. We use date underline range function. It starts, this is a starting date, and then periods 40, and frequency is 40 business days. Then we generate data 40 by 3. Now we can plot this graph just like before. So we define, plt.figure, we define the object. Then we add subplot, title, X label, and then we pass data. So plt.plot, dates is our x-axis, and then the first column is our y values, and the color is red. The second column is the second variable with the same x values, and the third column is the third variable. The color is blue, and we add legends. So let's say we assign some arbitrary names to each column. In this example, we go with bananas, apples, and oranges. Now let's implement this. First, we import datetime. Then we create date using pandas date underline range. A start is 2012, third month, and first day, and periods equal to 40 based on business days. So frequency equal to B. Okay, let's run this. If you print date, so you can see pandas, date range. So date.shape is 40. So you see 40 data points. Now we can generate data, the y values, and we use numerical Python, random, rand_n function, a standard normal distribution. The size is 40 by 3. And then we create our figure object. Fig is equal to plt, referring to matplotlib library, dot figure. Then the first variable, ax equal to fig dot add underline subplot. There's going to be just one. Then we set title, X label, so ax dot set title. Let's say fruits or fruit sales over time. X label, so ax dot set underline X label. Let's say it's for spring 2012. And then we can apply the plot function. So we plot dates on x-axis, then data, all rows, first column. Then the color is red, colon. The other plot or time series. Dates. The second column, and it's green, G dash. The third time series, color is B dash dot, and you're going to see the difference. And then we add legend, so plt dot legend. It's a list of 3 strings: bananas, apples, and oranges. Now let's run it. Okay. So there is a typo, it's just date, not dates. Let's run it again. And this is what you see here. So dots with color red representing bananas. So banana sales and spring 2012. Then lines with green color apples, and dash dot with blue colors oranges. So that's how you present 3 time series in one graph. Okay. We can also generate 3-dimensional graph. To do that, we need to import additional library named mplot3d. So in this slide, you can see how we can import this library. So from MPL underline toolkits, import mplot3d, then we will be able to plot 3-dimensional data sets. After importing the library, we add projection 3D to X object. And here you can see the example. We still define figure as the object. Then we pass plt.axis projection equal to 3-dimensional. So it shows that we are going to plot a 3-dimensional data. If you don't pass projection 3D, then we cannot set up the plot for 3 variables. Then we generate 3 variables, z, x, y, using arrange function for z. X is the sign of all elements generated in z, and y is the cosine of all the elements generated in z. And then ax dot, the function is plot 3D. Then we pass x, y, z, and you can change the color. So let's try implement this in a notebook so you can see what the results look like. So let's import the new library, which is MPL underline toolkits, import mplot3d, then we create the figure object plt.figure. Then we define axes. So there should be 3 axes. So ax equal to plt.axis. And we pass projection, which is equal to 3D. Then we generate data. Z is an array, mp.arrange function between 0 and 15. They are equally spaced by 0.01. Then y is just applying one function to all elements, so np.sine of z, and z calculates the cosine of z. Y calculates Okay, let me change it. So z is the original data, the randomly generated numbers. Then we have x, sine of z. Then we have y, which is the cosine of z. Then we can apply the plot function. We pass x, y, z. The color is blue. Now let's run it. And you can see this three-dimensional graph. You can change the color. You can set legend, add labels to each axis, and everything we discussed for formatting graph applies here. And the last thing, I would like to talk about contour plots. We can easily create contour plot. So first we generate two arrays, and here I'm using a new method named line space. So technically it's under numerical Python. So we generate with this, when we apply line space, the data points are between -10 and 10, and you set the number of data points. For example, everything between -10 and 10, but just 50. So it adjusts the step or the increments between the data points or the step value. Here you just pass the number of data points that you want to see, not the step value. So we generate x and y using line space, and then we apply mesh grid. If you remember, we talked about mesh grid method before. So we pass two one-dimensional arrays, and then it creates two-dimensional arrays, x and y, which is between all pairs of x and y. So x and y are two matrices generated from these two arrays. And then we define another variable z, which is y, whose values are y raised to 2 minus x raised to 2 plus x times y. So it's just a function that we define. And it will be applied to all elements in x and y. And then it will be stored in z. Then we want to plot this. So we create figure as an object, then plt.axis, it's three-dimensional. So projection is 3D. And then the function that we use here to generate the contour plot is contour 3D. Then we pass x, y, and z. Then the color map. Then we can define the color map, it's the binary. So when I run it, then you can see what it means. So x is numerical Python. It's the first time we are using the line space between -10 and 10, just 50 observations. Now, if I print x, you can see that it's an array between -10 and 10 and 50 observations. So x dot shape. So you can see 50 data points. When we use arrange function, then we need to pass the step value. But when we use the line space, we just specify the number of data points in the array. So y is also np.line space between -10, 10, and 50. It's technically the same array. And then we apply mesh grid function, and then we will have two matrices, x and y. So np.meshgrid. Then we pass two one-dimensional arrays. Now if you print x, then you can see that it's a matrix. So x dot shape 50 by 50, the same for y. Then I define another variable or matrix, which is y raised to 2 minus x raised to 2 plus x times y. If we print it, you can say it's another matrix. So z dot shape (50 by 50), the same size. Now we want to create the contour plot. So plt dot figure then variable ax is equal to plt dot axis. We want to pass projection to make sure this is a 3D plot. Projection equal to 3D. Then we can apply contour 3D. We pass x, y, and z 50. Then the color map is binary. If we run it, name plot. Okay, it's PLT actually, not plot here. Let me run it again. So you can see that it's in the grayscale, so color map binary, there are different options. And then you see X, Y, Z in this contour plot based on 3 matrices. Okay, and that's how you can generate contour plot. And with that, I wrap up our discussion about Matplotlib library.